So this project is related to simulation of semiconductor laser dynamics under high frequency modulation. Basically, in this article, we have just presented the semiconductor laser dynamic under high frequency modulation, wherein intricate the relationship between photon and carrier densities within the laser cavity and uh, meticulously examined through a rate equation based model. So the thing is that we are just estimation of the dynamics of semiconductor lasers under high frequency modulations have been extensively studied in our paper. So the photonic technologies are the modern technologies in our research, and this provide us the realization of next generation optical communication networks that rely on high performance semiconductor lasers. So we have just calculated the complete reliable optical communication systems in our driving innovation in the field of photonics, enabling the creation of faster, more reliable and more efficient optical communication networks. So I have written the complete abstract with the introduction and the detailed review of introductions, how it provides the setup, confrontation, research questions, approach, and the significance levels. Okay, so this is the layout of semiconductor laser dynamic under high frequency modulation. And I have added the background and context of in terms of high frequency modulations, and then I have just like for example this figure explains the modulation performance of multi-node high-speed semiconductor laser. For example, these are the modulation frequencies in gigahertz we have just defined here, 5 to 40 gigahertz, and these are the vertical line represents the modulation response of total power in dB basically. Okay, so the thing is that when the frequency modulation frequency increases, then the number of third, fifth, and seventh and tenth IB, tenth mean power of factors of third factor, fifth factor, seventh factor, and tenth factor of power modulation of total power increases according to different frequency levels. Okay, its levels are just performs according to the levels of frequency and it performs according to the power of in dB. So the challenges and the complexities in our cases as well approaches, because we are just facing the nonlinear dynamic and noise instability. We need to overcome these challenges and the complexities. The research objective is that we need to just underlying the physical mechanisms that govern their behavior as well. The significance and impact is that we need to just use the same like how the semiconductor lasers play a critical role in our high frequency under the high frequency modulations, and how we can improve the performance, reliability, and efficiency as well. Problem statement also added in it, and the methodology is this, and the rate equation model also added like how photon density rate equation, carrier density rate equation, and all the parameters like laser cavity length, photon lifetime, carrier lifetime, gain coefficient, and the modulation frequency levels varies from 1 gigahertz to 100 gigahertz basically. Okay, the validation is this, the mathematical models and the parameters are defined here. So the all the parameters are in terms of different constant values, different defined user defined values, The MATLAB simulation design methodology is here. Results and discussion also added here. Implications of different photon density versus time, carrier density, current versus time, as well as the photon density and frequency spectrum at gigahertz values. Okay, so these are the output results according to the MATLAB simulations for the specific PST over iterations basically. Okay, phase portrait of photon density versus carrier density. Okay, so after that we just concluded in our case, like we have used Range-Kutta method in our case to get the output behavior of the laser's non-linear behavior, including the oscillation and frequency chirping. So conclusion added future work also added, like how we can improve the accuracy and rate of equations as well, how exploring different laser structures, how we investigate the noise and stability as well, and the experimental validations also added in it. Okay, the references are included. So these are the MATLAB code for the modulation response of different range Kutta methods used with the different parameters, including in our range Kutta method as well. Photon and FFT we have used. You just run the project and you will get the output results. Okay, these are the complete MATLAB code accordingly, different parameters used in our cases. Okay, thank you. If you need to ask anything, you just ask me. I will answer your question. Thank you.